Yes, student. Now the next section is physical properties of aldehydes and ketones. Student, again we are dealing simultaneously aldehydes and ketones physical property because they are having the same functional group called carbonyl group. Okay, they are only differ by R and H. Okay, like here you can say aldehyde, this is R, C, double bond O, and this is what H. While in the ketone there is R, C, double bond O, and what is the difference here? The difference is there is again what? R. Okay, so this is the difference between aldehyde and ketone, H and R only, but the rest of the things are common. Therefore, commonly we are having the physical properties of aldehydes and ketones. So, physical property, first one what? State. That is what? Physical state. Student, as you know, the lower members up to 4 carbon atoms are liquid in nature. With what? Unpleasant smell. With unpleasant smell. Unpleasant smell means very bad smell. Okay? Like, student, the first compound of aldehyde, this is called formaldehyde. First compound is called what? Formaldehyde. Now, formaldehyde, its 40% aqueous solution is known as formalin. This formalin is used as disinfectant and also used for the preservation of animals in the lab. Now, in the bio lab, you have seen there a glass jar filled with some liquid, and there we can preserve any of the animal for longer period of time for our experiment purpose. Okay? So this is called what? Formalin. So these compounds are actually what? Soluble, but up to only what? 4 carbon atom. Okay? As the molar mass increases, that is the carbon number increases, the physical state, that is, they become what? Solid. Getting? Benzaldehyde and the acetophenone. Benzaldehyde is liquid, but most of the aromatic ketones are what? Solid in nature. Second one, which is again very important physical property, this is called solubility. Okay, solubility. You know, student, the compound is highly polar. How it is highly polar? There is a fraction negative charge and there is fraction positive charge. And water is also what? Polar in nature. So, being they are having the same nature, that is water, as well as this one, like C double bond O. Now there is fraction negative charge, there is fraction positive charge, and if you deal water that is H, it has fraction positive charge. Okay? And this is again what? O, and this is again what? H. So again there is fraction positive charge. So if we deal the next compound C or any of the thing, okay, any of the carbonyl compound. So again there is fraction negative charge. Thus the formation of hydrogen bonding takes place. Therefore lower members are soluble in water due to formation of which bond? Say simple, you can write what? Hydrogen bond. Okay, many times we already deal such properties in the previous chapter, therefore you can understand it very nicely. Like the question will ask, why do aldehyde and ketones are soluble in water? But can we compare aldehyde with ketone? Like here, R, C, double bond O, and this is what? H, this is aldehyde. Getting? And R, C, double bond O, ketone. Now out of this, which one will be more soluble in water? So student, in ketone there must be 2 R, but in aldehyde there must be 1 H. That means what? The electron repelling nature in ketone is very high, so ketone is less soluble. Ketone is less soluble in water. soluble in water. And even as the size of R increases, that is homologous series, as the size of R increases, the solubility will decrease. Why? Because R is called what? Hydrocarbon part. Hydrocarbon, and hydrocarbon are what? Hydrophobic in nature. Hydrophobic, that is water repelling in nature, and being it is hydrophobic, that is water repelling in nature, therefore the solubility decreases. That means the higher aldehydes and higher ketones are less soluble in water as compared to the lower member. If we talk about aromatic compounds like aromatic aldehyde or aromatic ketone, then aromatic aldehyde are somewhat soluble, but aromatic ketones are almost, you can say, insoluble or very less soluble. Why? Because in aromatic compound there will be bigger benzene ring, and these bigger benzene ring in aromatic benzene is highly hydrophobic. So aromatic compounds, so these are much less soluble in water. The third, again very important thing we have to discuss is called what? Boiling point. Getting? And the boiling point we discuss in two ways, like here first one. Okay, compare with hydrocarbon to which they prepare. Okay, because in IUPAC nomenclature we have seen that they derive from hydrocarbon. So if we compare with hydrocarbon, okay, of almost same molecular mass, almost same molar mass, then carbonyl compounds are having more boiling point, Now, why do they are having more boiling point? This is due to special type of attraction force. This is called what? Dipolar attraction force. While in hydrocarbon there is only London force, or you can call it what? Dispersion force. But here it is having what? Dipole attraction force. Therefore, their boiling point is very high as compared to the hydrocarbon. But if we compare it, okay, with alcohols, now student, you know that alcohol is having what? Hydrogen bond, and if there is hydrogen bond, that means this type of attraction force is called very strong attraction force among all type of intermolecular attraction force. Therefore, alcohols have very high boiling point, as compared to carbonyl, compound, that is carbonyl compound with the same molecular formula, okay, and molecular mass, with same molecular mass. Like if we compare our first compound, this is CH3, CH2, CHO. This is what the propionaldehyde. What is it? Propionaldehyde. If we compare next compound, CH3, CO and CH3, and if we compare it with the propanol, CH3, CH2 and OH, this is what? Propanol. All these compounds have almost same molar mass. That is what? Its molar mass is 58, its molar mass is 58, its molar mass is 60. But the boiling point is what? The boiling point of aldehyde is 322, while the boiling point of ketone is 329, while the boiling point of propanol is 371. That is what? Very high. 371, this is called very high boiling point, almost 2 degree less as compared to boiling point of water. Therefore, these two compounds are highly volatile in nature, means propionaldehyde and the propanol are highly volatile in nature as compared to alcohol. Alcohol is also called volatile. Why do these are called volatile compound? Because their boiling point is very low. All these at room temperature present in liquid state and called a volatile compound. Now student, what is the reason? The reason is in alcohol there is hydrogen bond, get it? They also form hydrogen bond, but due to presence of this group, that is they are called dipolar in nature, therefore their boiling point is comparatively less. Now if you talk about the boiling point comparison between aldehyde and ketone, look at it, this is aldehyde and ketone, the boiling point is 322 and here the boiling point is 329 Kelvin. Are you getting? That means of the 7 Kelvin is more. What is the reason of it? The reason of is in acetone or in ketone, the dipole moment is little high as compared to the dipole moment in benzene or in propionaldehyde. Actually, the dipole moment here it is 2.8 while the dipole moment here 2.88. That is, the dipole moment, as greater dipole moment, more will be the boiling point. So, being the dipole moment of acetone is more as compared to propionaldehyde. Now, why its dipole moment is more? It is because the carbonyl compound is attached with two alkyl radical and these two alkyl radical have electron releasing nature. So, they releases electron on carbon, therefore, O become more electron efficient while there is no such condition. Okay, therefore it has higher boiling point. Yes.